all students will be able to review the rules of exponents in preparation for exponential functions. Exponent of 1. A to the first power equals a. Any number to the first power is the base. Why? If a squared means a times a, then a to the first just means a. 2 to the first equals 2, 7 to the first equals 7, 10 to the first equals 10, 4 to the first equals 4, x to the first equals x, and g to the first equals g. Pause this video, rewatch it if necessary, and fill in the top row of the chart on your notes. Exponent of 0. A to the 0 power equals 1. Any number to the 0th power is 1. Why? There's a hidden coefficient of 1 in front of a. So a to the 0 means 1 times a to the 0. This means 1 times no a's. 1 times no a's is 1. So 2 to the 0 equals 1 times 2 to the 0, which is just 1. Or 7 to the 0 equals 1 times no 7's, so 1. 10 to the 0 equals 1 times no 10's, which is 1. 4 to the 0 equals 1 times no 4's, which is 1. X to the 0 equals 1 times no x's, which is 1. G to the 0 equals 1 times no g's, which is 1. Pause this video, rewatch it if necessary, and fill in the middle row of the chart on your notes. Negative exponents. A to the negative b power equals 1 over a to the b power. Negative exponents can be written as positives in the denominator of a fraction. The coefficient remains in the numerator. This will usually result in a fraction or decimal. Why? If a to the b power means that you should multiply a b times, then the opposite, or negative b, would mean you should divide a b times. So 4 to the negative 3 equals 1 over 4 to the third, which is 1/64. 10 to the negative 2 equals 1 over 10 squared, which is 1 over 100. 2 to the negative 5th equals 1 over 2 to the 5th, which is 1 over 32. X to the negative 6th equals 1 over x to the 6th. And last but not least, m to the negative 8 equals 1 over m to the positive 8. Pause this video, rewatch if necessary, and fill in the last row of the chart on your notes. On the practice problems of the problem page, you'll see that there are some problems for each of the exponent rules we have reviewed. The first two are about the power of 1. What is 300 to the first power, and what is x to the first power? Review your table at the top of your page, and when you're ready to answer these questions, press play. At the top of your page, you should have read that anything to the first power is equal to the base. This is equal to 300. And this is equal to x. In the next section, we have two problems about the power of 0, 300 to the 0 power and x to the 0 power. Pause this video, review the chart at the top of your page, and when you're ready to continue, press play. 300 to the 0 power is equal to 1, and x to the 0 power is equal to 1. If you need to review why, there's actually a hidden multiplier in front of 300. So this really says 1 times 300 to the 0 power. Well, this means 1 times no zeros. No 300s. So 1 times no 300s just equals 1. It's the same reasoning over here. This really means 1 times x to the 0. 1 times x to the 0 means 1 times no x's, which is just 1. Now we have some practice problems about negative exponents. Let's try a few together, and then you'll try a few on your own. 5 to the negative second power can be rewritten. We're going to rewrite it as 1 over 5 to the positive 2 power. So you'll notice that these negatives became a positive in the denominator. What is 5 squared? 5 times 5 is 25. So on this problem, we have 1/25. Keep in mind that negative exponents usually leave fractions or decimals. 3 to the negative third. Think about how you could rewrite this. It's going to be rewritten as 1 over 3 cubed. What is that equal to? That's equal to 1 times 3 times 3 times 3, which is 27. So this is equal to 1/27. Last but not least, x to the negative eighth. That can be rewritten as what? That can be rewritten as 1 over x to the 8th. Since we don't know what x is, we can't really take it a step further. It's just going to stay like that. I'd like you to try these three on your own. And when you're done with all three of them, I'd like you to press play on this video again. Right now, go ahead and pause it and do the next three problems. For the first problem, you should have written 1 over 10 squared, which is 1 over 100. For the second problem, you should have written 1 over 2 to the 4th. Remember, they're always positives when you write them in the denominator, which is 1 over 16. And last but not least, you should have written 1 over x to the 20th power. The 20 should be positive since you have it in the denominator now. I want to try a few tricky problems. Now, even though these are tricky, these will definitely come up when we're doing some problems in Unit 2, so we have to go over it. So this one's tricky. Well, I know that I can rewrite this as a positive if I put it in the denominator. So I'm going to go ahead and put that in the denominator, like this. So I rewrote it using a positive exponent, but I put the 1/4 to the first power in the denominator. Now take a look at this right here. Anything to the first power is equal to the base. So that's actually equal just to 1/4. I'm going to go ahead and erase around it and just leave the 1/4. So I have 1 over 1/4. Well, you may remember that dividing, right here, because we're dividing by a fraction is like multiplying by the reciprocal. So I have 1 times, now I'm taking the reciprocal of 1 over 4, which is 4 over 1. Okay, so please remember, dividing by a fraction is the same thing as multiplying by the reciprocal. So what I did is instead of dividing by 1/4 over here at the top, okay, instead of dividing by 1/4, I just multiplied by the reciprocal. So I took the 1 over 4 and I took the reciprocal, so that was 4 over 1. Okay, so anyways, coming to our final answer, 4 multiplying across, we have 4 over 1, which is 4. Okay, we're going to do it a different way now, but please remember the answer is 4. So here, I can also convert the fraction to a decimal first. What is 1/4? 1/4 is also called 0.25. Now I can rewrite this by putting the negative exponent as a positive in the denominator. So I put it as a positive exponent of 1. But I also know that anything to the 1 power is just itself. So you get 1 over 0.25. Now this isn't done yet. The reason why you might want to use a decimal is because you could plug this into a calculator much easier than this situation, right? That you can't really put into a calculator. But if you had a calculator, you could put this into a calculator. And if you did, guess what you would get? You would get 4. So that's pretty tricky because you had a fraction to a negative exponent. Your options are to use the reciprocal. Dividing a reciprocal is like multiplying by the, dividing by a fraction is like multiplying by the reciprocal. Or you can just divide using the decimal. Here are 3 problems. I'd like you to pause this video now, do those 3 problems on your paper, and press play when you're ready to review. So here are the answers I have for the 3 you try problems. The first answer I got is 25/4. I got that by, let's see, the first thing I did is I put the whole entire thing down in the denominator, but with a positive 2. And then if I have 2/5 and I'm squaring it, that really means it's multiplying by itself 2 times. So I wanted to show you what that looks like. Okay, now down here I multiplied across, so I get 4 over 25. And then I use the concept of dividing by a fraction is equal to multiplying by the reciprocal. Multiplying across, I get 25 over 4. For the second one, I did the same exact process. So I took this negative 3 and I wrote it as a positive down in the denominator. And then I actually wrote it out 3 times because it's being cubed. And that was 1 over 1/27. Then, instead of dividing by a fraction, I multiplied by the reciprocal. So I got 27 over 1. And in this case, 27 over 1 is just 27. For the last one, I have 3/4 to the negative 2 power. So I used that negative 2 and I wrote it down as a positive in the denominator. And that means times itself, so I showed it multiplying out 2 times. Multiplied across the top, 9 over 16. And then I multiplied by the reciprocal. So 16 over 9 is my final answer. Thanks, Honey Bunnies.